Hello again, welcome to Pandabood tutorials. In today's video about electrical circuits, we will be talking about what are conductors and insulators. Let's start. Now, what about conductors and insulators? Conductors and insulators are important in electricity and also as well as in heat. So conductors are the devices that conduct electricity and let the electricity to go in them. Now these wires are all made of conductors, which mostly copper, which is a great conductor and also cheaper than silver, but there are other conductors too. For example, let's keep the same circuit we're using here and let's turn the values off. I will show you later why. Let's remove this resistance and let's put the voltage to a reasonable value. Now this is my circuit. What do you think will happen if I connect different parts of materials here? So let's start with the paper clip. Since it's made of metal, so it will let electricity to flow in it, and you will see the circuit will be working. What if I change this paper clip, which is a conductor because electricity flows in it, with a dollar bill? This is $1 bill made by FET. It's connected and see, it doesn't work. Why? Because it's an insulator. Insulators, you can think about insulators as devices or materials with infinite resistance. Or look at this number. How many zeros here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 billion resistance. That's why the current is really small, which approaches to zero. Now let's bring the paper clip back and see the reading. It's zero because it's a conductor. What about the coin? As you can see, it's 0 ohm, so it doesn't have any resistance. So what do you think? It will be conducting the electricity, so it's a conductor. What about the eraser? You saw it. You saw the numbers, so it's gonna be an insulator. Rubbers are insulators. And what about the pencil? People think of pencil as wood, and woods are insulator, but the inside of the pencil, as you can see in the picture, both sides have this pencil sharpened. So this pencil has the graphite inside, and it has some resistance of 25 ohm, but it's still a conductor. It's not that good conductor, but it's still a conductor. And as you can see here, my circuit is working. That's why we always advise young children not to play with the socket at all, and especially with pencils, because they think this is wood, it's not gonna work. But if both sides have the graphite out of them, then you can get shocked by electricity. So this is about conductors and insulators. Now someone can ask and say, well, don't wires have a resistance? And the actual answer is yes, they have resistance. Just for the sake to make this simulation works easier, we turn them off. But if you go to advance here, you can see that there is some wire resistivity, and it will affect the circuit. So let's put some wire resistivity here, and you will see that it's less bright. Now let's add some length to this wire and try to keep your eyes on the current. Oh, it decreased. Why? Because resistance in wires is more when the length of your wire is more. Think about it. There is more distance for electricity to flow. That's why it will be less the further it will travel. The further it will travel, the less current will be there because there is more resistance in your wire. So let's add more of the length, you see. But if I turn this off, it will be normal, as if it's close or far away. But in real life, if you're having a science project and you're trying to build a circuit, don't use long wires in your circuit. Something else affecting the resistance of the wires is the thickness of them, but this is again a topic for another time. Right now, what I want you to know is, when you have longer wires in real life, you have more resistance. Longer wires, more resistance. Shorter ones, so less distance for electricity to go, so less resistance and therefore more current. Guess what? The battery also has a resistance, but normally it's tiny. It's reduced as much as we can, so it doesn't affect the circuit. But also the battery has resistance, the wires has resistance, but just for the sake of simplifying this, we just put them to tiny. If you want to explore, it's right here in the advanced option. That's it for today. See you next time. Pandabood.